Hello and welcome to a new edition of Digital Dish, organized by Ljudmila and Projekt Atol here in Ljubljana. Today we have special guests from Germany, from Berlin, and in, let's say, the next 2 hours, we will be talking about media archaeology. We have 2 lectures today, first by Wolfgang Ernst and then by Stefan Höltgen. Wolfgang Ernst is a full professor for media theories at the Institute for Musicology and Media Science at Humboldt University in Berlin. His academic focus has been on archival theory and museology before attending to media materialities. His current research covers radical media archaeology as method, the epistemology of technologos, the theory of technical storage, the technologies of cultural transmission, microtemporal media statics and their chronopoetic potentials, and sound analytics, in other words, sonicity, from a media epistemological point of view. Ernst's most recent book in English is entitled Technologos in Being, Radical Media Archaeology and the Computational Machine. Wolfgang's talk lecture today is entitled Against the Dead Media Metaphor, Objectified and Processual Media Analysis in the Media-Archaeological Fundus and Radical Media Archaeology as its research method.
Hello, good afternoon. Thank you to the Ljudmila team for the kind invitation and opportunity. Now, I will try to explain to you why media archaeological objects are not necessarily dead media. Welcome to the Media-Archaeological Fundus, which you see here in the background. This is a live transmission or live streaming transmission from our Media-Archaeological collection of media science at Humboldt University. We are here both conceptually and spatially, locally, located opposite of the Berlin Museum Island. I always like to say opposite. In the Pergamon Museum, you visit old antiquity, and the Media Archaeological collection, this is the new antiquity of our media cultural age. And by its sheer location, the Media Archaeological Fundus is already situated. By coincidence, as announced by an inscription at the entrance of our Media Archaeological collection, one realizes that this has been philosopher Hegel's previous house. He has been Humboldt University's first professor of philosophy. And Hegel's critique of the mechanization of human thought, which we nowadays call computer, and he knew it already from his contemporary Charles Babbage in London, who constructed his difference engine. This critique of Hegel against the machines, against computation, already poses a challenge to the ambitions of a technology-focused media science. And I'm aware whatever I say to you now will be critically and dialectically counter-checked by our house ghost, Hegel. The Media Archaeological Fundus consists of material media artifacts, which you see in the background, partly reaching back into the 19th century. But this is not a museum collection. The Media Archaeological Fundus is an ensemble of core technological molecules or atoms, how I would call it, which at first glance look historically outdated, but become radically contemporary once they are deciphered with media archaeological eyes, ears, and minds. An archaeology of media, in the sense of the Berlin School of Media Science, is not primarily about the past, but addresses technological objects in a continuing operative present. This leads to a non-historicist comprehension of media time. Most important, the objects which are assembled here are still maintained functional, at least in principle, respecting their vulnerability at the same time. From there, the very denomination fundus derives from theater. A fundus, in the strict sense of a pool in theater, is a repository of props, once produced for previous performances, but maintained for reuse in new dramatic contexts. Media theater, where technical objects from the fundus are literally reenacted, is our other central place. Media theater as stage, where technical media, rather than human actors, are the main protagonists. The more the actual technology of communication and knowledge, media, is hidden in microprocessors, which you cannot see, not hear, not touch, the more a three-dimensional counter space is required to reveal such implicit signal action, such as, for example, Alvin Lucier's seminal media installation called I'm Sitting in a Room from 1969. This can only unfold in a combination of a physical space and acoustic with its recursive recording by a magnetophone. So that's why we have a media theater next to the Media-Archaeological Fundus and the Signal Laboratory as well. Back to this place here. These artifacts have not been collected for nostalgic reasons, but for students of media science and media scholars to be analyzed and touched in action. The Media-Archaeological Fundus is by no means a historical or museum collection, but among other issues, demonstrates that the age of technological, especially digital media, in its components has been anticipated much earlier. The objects have to be maintained functional. This is the difference to the showcases of a technical museum. In order to recognize that, for example, the electromagnetic relay as used in automatic telephone line switching, and I take one. This is the classical electromagnetic relay. This device has been for telephone switching connections, but then has been misused, so to say, in early digital computing for its binary quality of on and off. I can even manually click the on and off. So telephone technology became the core of the first digital computers. Or let's take telegraphy. Before telephony, telegraphy has been a digital communication, dots and dashes. Then it was succeeded by radio and telephony. Now with digital communication, telegraphy, zeros and ones, returns. So the digital has preceded the analog media in 19th century, and that's why we, for example, have this telegraphy equipment. And this is the most digital device you can even imagine, because with your fingers, Latin digits, you start telegraphing dots and dashes. So our media time is subversive of the classical narrative of progressive technologies. The Media-Archaeological Fundus, together with the Signal Laboratory and our media theater, they constitute a trilogy for the analysis of media. And colleague Stefan Höltgen will later report from the Signal Lab. Our media theater, I have already mentioned it. Now here, the Media-Archaeological Fundus is no collection of technical artifacts in the traditional sense, like so many private collections of, for example, antique radios. The imperative for this fundus existence and maintenance within a university context is strictly academic. But what is academic in a brute technical object? It is the implicit material and logical knowledge which invites to be media analytically unfolded, to be made explicit in media epistemic terms. In contrast to technical masterpieces, which are kept in museum showcases, but are not allowed to be touched, even less be reenacted for media scientific analysis and education, a different set of objects comes into consideration, which might not be attractive at first sight from a public point of view, but is highly interesting in terms of close knowledge-oriented investigation. And now let me talk about a few concrete objects. The most obvious, monstrous technology which we have here is the Ernemann cinema projector from the 1950s. You can have a quick look at this monstrous film projector from around 1950. Media have a very material presence indeed. Like a sculpture, it is posed here in our Fundus, as opposed to the ancient Greek and Roman sculptures opposite in the cultural museum. So this is a nice contradiction or counterexample of old and new antiquity. And this film projector is not only kept for its obvious demonstration that it unrolls celluloid reels, but for an insight into its more sophisticated mechanism. For example, to show that film does not unroll continually in a film projector, but every frame is made to stand still for a fraction of a second. And we can see this by a close examination of the core of the projection mechanism. And from this media knowledge questions arise. How can a technical mechanical medium stop and go mechanism betray our perception of a continuous cinema movement? So we start this kind of insight from the concrete object. And from here, we link it to the computer, because the inventor of the computer, of the Turing machine, Alan Turing, he wrote in the mid-20th century, for digital media, they have to treat time as discrete. That's what Turing explicitly wrote. So the cinema projector and the classical mechanical clock, which by the escapement mechanism discretizes continuous time into identical quantized time units. This mechanism links the cinema projector to the clock, and this links to the digital computer in Turing's sense. So those are unexpected interconnections which we demonstrate by real operative objects. You can see this mechanism is operative, actually, and it has to be operative. It's not enough to show it just simply as an image. An ancestor of this film projector by the same company, Ernemann, still revealed the rotating wheel open, naked technological display. That brings us to another core imperative of the philosophy of our Media-Archaeological Fundus. Because once we have objects coming in, the technical objects are radically dismantled from their cover in order to reveal their technological essence against the perceptual reduction by the surface design or the interface, which rather directs human attention to wrong associations. The Media-Archaeological Fundus works against kitschy media surfaces to get users to understand the underlying workings of, say, a radio. And I can quickly show you two radios. This is a radio, how philosopher Heidegger had it in his house. That is how he writes then about radio. But we have the same radio dismantled to see the essence of the radio. Actually, I should now put off, you see, one can get one's hands dirty in the Media-Archaeological Fundus. That's why we have this engineering dress normally if we work in the Fundus. But you see here both how we want to see archaeologically the same medium which is normally hidden behind the surface. And you write and you philosophize about technology in a different way if you see it's from its technological insight and not just from its user interface. So those are core ideas of our Fundus. And we have to come to the digital age. In a world where communication media are miniaturized to the max, and when you use your smartphone, you get no insight into its inner technology. So when the microprocessors become extremely minimal and hidden to unrecognizability in the Internet of Things, even students of media lose contact with what happens within such digital technologies. An assemblage of archaic media still reveals such principles, but in contrast to miniaturized components, such as integrated circuits, they do it in haptic, macro-perceptible ways. Therefore, media archaeology is not primarily directed to dead or forgotten media from the past, waiting to be rediscovered or even to be excavated metaphorically, but archaeology is rather understood in its old Greek sense, and now I write it here, of arche. Archaeology is related to Old Greek arche, which is the core of the word archaeology. And arche means not only origin or beginning, but it also means the essential. And that's what media archaeology is about. Not about the historical past, but the essentials of media. So media archaeological analysis reduces so-called media to their technical essentials in order to keep them comprehensible. I hope I should not hide the microphone. While most users in everyday media culture count the capacities of their smart devices in megabytes, the idea of what is a bit, 1 bit, is actually, where does it place? Recedes. And that's why we have what we here have, the so-called flip-flop demonstrator constructed by Henry Westphal from Tigris Electronics in Berlin. And most humans know bits only as symbolic zeros or ones, which of course is not the case for the technical existence of binary information units. Therefore, the Media-Archaeological Fundus has been granted on loan this flip-flop demonstrator for educational use. The earliest known binary computing, consisting of 2 cross-related triode vacuum tubes, which you see here, they have been borrowed from radio technology as a misuse and are reused for binary calculation. So it started from radio transmission engineering and was misused now for the first computers to store 1 bit. And suddenly 1 bit becomes materialized. And it says, be careful, there is high voltage, so I have to be careful, especially with the hot, wet weather. But if I switch it now on, there is high voltage. You see here 1 lamp indicating where the bit is stored. Now I reset it, and now it keeps the other value. So how can electricity become information by keeping 1 or 0. This is indicated by this cross-related first flip-flop, and we actually have 1 bit here. Now suddenly we can touch, we can see, we can experience the core essence and core unit of information technology. This is media-archaeologically reductive, but explanative at the same time. And now I show you, because I should come to the end of my presentation, why we collect media epistemic toys as well. There has been a toy car, which I show you here, by the former GDR toy industry, the so-called Kubernetes. From the 1970s, you see it says here Kubernetes, and this is the toy car. And at first sight, you say, why does Humboldt University collect a toy car? But this battery-driven car could be programmed, in quotation marks, with elementary units to decide on its direction by the car wheel mechanism. And it therefore becomes an automat. Even if lacking an actual mechanism for negative feedback, it served to playfully adjust children to the principle of cybernetic government, which in both East and West, for a whole epoch, dominated avant-garde thinking. Of course, it's vital that we experience how we program how it goes, left, right, straight forward. We switch it on, and then it starts to actually go the way I have programmed it. We need, of course, the media theater otherwise to really let it go. It's a bit small here. But you see why we even collect toys if they provide epistemic insight. And suddenly it switches from programming in hardware to the computer language logo, where a similar mechanism can symbolically be programmed. So we take care both of the material presence and action of technology and the logical aspects, which is the programming, which you cannot touch. But if it runs a program, it is in action, and then it's in a media being. And finally, I show you how a cigarette finds its way into a technical collection. I will take it now. Here. Okay. You can even see the cigarette is close to Friedrich Kittler's media theorist's personal, playful circuit construction. Now, why do I put a cigarette? It's not to adore Kittler, who was a very heavy smoker. But there is another precise reason why we collect it. It's a little detail, and that's what we train in education of our students, of this cigarette, which makes it a media interesting thing. It's the little gold stripe in the middle, separating the filter from the tobacco. You see this little gold stripe, this little filter. Now, this links it unexpectedly to the invention of the magnetophone of sound recording in the mid-1920s by Fritz Pfreumer in the city of Dresden. At that time, as a member of a cigarette company, Pfreumer had been concerned with the application of metallic filter against intoxication by smoke. From that, he suddenly derived that if metallic dust can be fixed to such cigarette paper, one could as well magnetize such paper by the varying current of electronic voices, as known from telephony. by the well-known core media operation of electromagnetic induction. Thereby, Fleumer invented what he called the singing paper, which later became the magnetic tape, as I maybe show you the magnetic tape, because of course most of you belong to a generation where even the magnetic tape is a media-archaeological object already. So this gives you an idea of core ideas of the media-archaeological fundus. I think my time is almost gone. I simply quickly want to say, because we are here invited by Slovenia, Ljubljana, creative space. Another object which we have in the fundus is the owner's workshop manual to the Yugo car, the famous Yugoslavian Yugo car. And the manual allows to analyze a car by describing every component. And by every component, you can, like in a chronographic film, recompose the car from its simple elements. So you can analyze and rebuild a machine simply by the diagrams. You have a diagrammatic running car. So the Yugo, although it's a book here, is actually an operative diagram in terms of media archaeology. So this is my special greeting to the legendary Yugoslav Yugo car. And now we come to the signal laboratory. I will in a few seconds hand over to Stefan Höltgen, because I want to insist that we know that media cannot be reduced to the material haptic object only. This would be a wrong understanding of media archaeology. Technology consists of two parts in the word. Technology. The techno is the material, machinic, haptic part of media, but then there is the logos, the logical part, such as software. And of course, can we collect software? Can we exhibit software nicely, like we exhibit a clock? We cannot. But still, we take care of software, because then we come from the material to the mathematical part of media. And I want to insist finally against the dead media metaphor of media archaeology. Media archaeology is always about mathematics as well. And I call it radical media archaeology. And I write it like this here, the word, the radical, with the mathematical radix sign to show if you want to analyze media, you have to be very detailed with the material analysis, but with the logical analysis as well. That links media archaeology to mathematics. And that's why it becomes radical in the square root sense of the word. So I think this was, I exhausted my time. Now I hand over to Robert Bobnič, who will introduce my colleague in the signal laboratory, Stefan Höltgen. Thank you for listening, and I will look forward to the discussion.
Thank you, Wolfgang, for this presentation and lecture. And I'm really glad that Yugo is not dead for you. So it's alive and operative in your fundus. So that's really good. So now our next guest is Stefan Höltgen. Stefan Höltgen is a scholar for media science, also at Humboldt University in Berlin. There he researches and teaches media and computer archaeology, curates the department's media and computer collections, and works as a scientific advisor for the Oldenburg Computer Museum. The title of Stefan's lecture or presentation is Signals and Noises, Scenes from a Retro Computing Hacker Space. So, Stefan, the floor is yours. Welcome.
Yes, thank you very much for the invitation. At first, I have to apologize. It may be that we face some audio problems since we used the USB cable that couldn't transport the audio signal from our camera to the computer. So I hope you can hear me right now. Yes, okay. So yeah, welcome to the Signal Laboratory. It's kind of a follow-up of the lecture from Wolfgang Ernst, since the Signal Laboratory is the second laboratoric institution here at the Department for Media Studies, or Media Science as we call it, at Humboldt University. And here we are in a kind of workroom, which is also a seminar room. Here my own classes about computing and about hardware and software preservation and things like that are happening, but also it is a place for research, and it is a hackerspace too, where regularly every month, but not now until Corona, but regularly every month, hackers from all over Berlin and nearby cities meet to show their new gadgets and to talk about how to repair and how to collect things and computer stuff like that. Yeah, the Media-Archaeological Fundus is a place. First, I want to show you the place. And then I will discuss some of the tools and some of the toys we are using here to give you an insight to the focus I myself have on computer and computer archaeology. And I thought about what I can do for this talk, what I can show you. And 2 years ago, I had a seminar which had the title Pong Studies. It's a bit ironic to cultural studies, Mickey Mouse studies, and so on and so on. But Pong Studies was the idea to analyze different implementations of the famous or infamous tennis game for different platforms, from analog computers to TTL boards up to software implementations. But to the Signal Laboratory itself, here you can see a shelf. You should use the big screen for the Signal Labor camera. Here you can see a shelf with retro computers or historical computers from the 1970s until the 1990s, mostly 4, 8, and 16-bit computers. They are all in operational status, since when we get them and they are defective, they will be repaired, and the reparation of the computer is a kind of a reparation of knowledge as well, to get an idea of how the computer works by looking at his errors and his faults. So all these machines are in working condition, and we are using them regularly for experimentation and for classes. Since all these computers here are so-called von Neumann machines, and as von Neumann machines, you can program them as any other von Neumann machine. So you can learn from a C64 how to program a machine, how to program a computer, and the things you learn by doing this with the C64 can be expanded to any other von Neumann machine, even to your iPhone. But microcomputers are not the only things we have here in the Signal Laboratory. The camera shows right now some mini computers here from digital. There's the PDP-8 and the PDP-11. And with these computers, we use, as with some other computers, retro gadgets as add-ons. So our PDP-8 uses a USB drive and not paper tape or hard drive anymore, a USB drive to load stuff and to work with the terminal. And this is the idea of media archaeology as it is of computer archaeology, that you can confront the so-called past with the so-called present by showing that a thing like USB can be put onto a historic computer as well. Another thing is that we are collecting toys and computer games and video games, and these video games have mostly an epistemological sense, where you can, as Wolfgang Ernst just said, find out in a toyful way, in a kind of gamification process, how technology works. And especially with games, you can see some of the aspects of digital media very clearly and in a very broad sense. And on the other side of the laboratory, there are some here are some analog computers. I will click on this analog computer here in a few minutes to show you the first implementation of a tennis game. But there are also some teaching analog computers, like here this Leibold Harreros computer from the 1970s, which has been used in schools. Here's you can see an implementation of a Lissajous-Figur, where you could put on an oscilloscope to draw it onto the screen. Okay, yeah. As I said, I want to show you some things that we are doing here in the Signal Laboratory. And this is, and the idea of my talk is to confront, let's say, media historic gossip with the technology itself. So I want to show you with every machine I will show you right now a specific thing we have thought of when we did that. Here is an analog computer from Telefunken, and we used this in 2012 to implement the Tennis for Two game from right there. I will switch it on so you can see our implementation. It takes a little bit to get warm with for the oscilloscope to get warm, so you can see the cathode ray. The implementation of the program you can see down here. This is a wired kind of programming, since it has nothing to do with symbolic programming with digital computers, but it's an analog computer, as I already said. And an analog computer is a kind of simulation machine where you can simulate processes with the with electricity, with the changing of electricity or voltages that can be showed and can be seen on the oscilloscope. So when we started to implement William Higginbotham's Tennis for Two, we didn't use his original scheme. There's a drawing of his analog computer game as a scheme on the internet, but we followed the path he had gone himself, since he used a physical demonstration he found in the manual of his analog computer, and this was a demonstration of a jumping ball in a box. Think about a box where you put in a gummy ball, and this gummy ball starts to jump around and it's reflected by the walls. And this process has been simulated with an analog computer. And William Higginbotham thought of opening the box, the left and the right side of the box, and putting some triggers there so that the ball could be hit forth and back. And so we used the very same demonstration for this Telefunken analog computer from the 1960s and try to reenact the way of opening the box. If you can understand this as a metaphor. So, and here now we have this implementation. I will start it right now. We have to load the capacitors, and hopefully, yeah, okay. It takes a while since here we are. Here we are. You can see we can play the ball forth and back. So it works. But our implementation lacks of a tennis court. William Higginbotham used a tennis court. He showed a tennis court on his oscilloscope, but we didn't do this since there are no more operational amplifiers we could use for that. And so we found out by looking closely at William Higginbotham's scheme that his analog computer he used didn't produce the tennis court as well. He used a kind of electronic board he put onto his computer that only shows this tennis court as a mathematical function. Okay, this is the first stage. The second stage, of course, when we speak about Pong, is Pong. And here we have an original Pong board from 1972. I bought it on eBay for $150, and it was, of course, defective. There were even some of the ICs of the TTL ICs broken, so you could see the dice. But a friend of mine managed to repair this for us. So now we have here a working Pong. You can play Pong against each other. It's a two-player game, as you all know. when we did the seminar on Pong studies, I'm a very bad Pong player. When we did the seminar, we were amazed about the sounds the system produces. Since there's a saying that Alcorn had finished the board, and then his chef came to him, his boss came to him and said, okay, a fine game, but now we need sound. And Alcorn said, there's no more place, there's no place on the board, I can't put any more ICs on the board. And the saying is that he poked around with his oscilloscope to find any signal that could be made, that could be amplified to be a sound. And he said, I found 3 or 4 of those sounds and amplified them. And this is one thing we found out by looking at this board and at the chips that isn't all true. Since there's one IC here, a 555 IC, you probably know this is a timer chip that has no other use than to produce a specific length of a sound that is put out. And if you look at the scheme, you will see, okay, this IC is only used for sound purposes. So Alcorn used another chip and put another chip onto his board to play the sound. One of our students in the Pong seminar even looked closely at the circuit diagram. Sound devices from Pong here on the breadboard, and he managed to find the right frequencies and made a machine where you could replay the Pong sounds. I don't know if you can hear this. These are the frequencies that the Pong board produces with discrete elements on a breadboard. So analyzing a video game is not a thing of aesthetics here at the Signal Laboratory, but more of the combination of the electronics and the historical and epistemological things that are built in such a machine to produce that aesthetics, the so-called a prioris. Okay, I have to be a bit faster to put up the show. Now this is Magnus Odyssey, another tennis game from the early 1970s, and as you all know, there had been some difficulties between Ralph Beer and the inventors of Pong, who was the first one who introduced such a game. And this is quite different technology than the Pong board. When the Pong board is a TTL board, which you can call digital if you like, this is a kind of hybrid analog thing, which mostly is used to produce TV signals. And here we have a very bad TV signal. This is one of the things that are put this center. Yeah. Where's the ball? The ball is missing. Okay, but that wasn't the thing I wanted to show you. Here you can see here there are cartridges to put in the machine, and these cartridges seem to contain the game, but they don't contain any software. They even don't contain any hardware. We took one of those games out of the case, and we moved the plastic. And the thing you can see here is that these games are more or less like jumpers. It's a jumper where some of the contacts are connected and some are disconnected. And this is so you can say this is a kind of hardware extension to the video game console to complete the console. If you put out the module, the cartridge, the console, the video game console wouldn't run. But if you put it in, then it is completed. No, there, whatever. Yeah, and so some hacker, not from Berlin, not from our space, came to the idea to produce new games for this machine just by tinkering around with these contacts to see what happens if I connect these contacts and put it back into the machine, and 3 new games came to the world. and you can say these games were already existing in the machine, and just by connecting the contacts came to life. So this is one thing which is very interesting about the Magnus Odyssey, since you can't decide if a game is hardware or software or what is a game. Here at this station we have so-called home Pong consoles, and a home Pong is a machine where the Pong game is the Pong game. A home Pong machine is a Pong game where all the games are put onto one chip. Here on this chip, this is General Influence chip from 1978, where all the games are put on. And there were dozens and dozens of those home Pong consoles on the market. And these are just three here, even one from the GDR, a GDR console of Pong, which also uses the very same chip. So there is nothing GDR except that it has been put together in the GDR. Everything from the electronics is not from the GDR, I would say. But interestingly, there is an undocumented game in this Pong chip, and you can reach this game if you put the game, the switch to choose the game in between two specific positions. And there you will see an undocumented game which is called Soccer for Five. Soccer for Five. And we were amazed about how the machine could produce such a game, and wanted to find out how this glitch was happening. And this has just started the process with contacting the physics department to open such a Pong chip. And we managed to open the chip, and perhaps you can see the open chip here in the microscope. And the next step would be to let's say to analyze the structures of this chip with the help of guys from the electronics and so on. Yeah, here you can see, you can take a glimpse on this tiny chip, but it's huge compared with modern microelectronics. Yeah, and by analyzing this chip, we try to find out how this glitch can happen. It seems to be that here, since the IC of the Pong chip contains, as any IC, these tiny legs here, and each of these legs has to do something with the graphics, or with the sound, or with the game chosen, or with the counting of the score. That by switching in between two positions, two or more of these tiny legs are affected and produce those signals. Yes. Okay. Yeah. And the last stage, switch that off. The last stage is when Pong has become software. This happened in 1977 when Jody Quire programmed the Video Olympics for the Atari VCS console. The VCS console came to market with this cartridge where you can find 50 Pong-like games. So you can easily switch from the home Pong console to the Atari VCS. And here, one very interesting thing happened with the Atari VCS Video Olympics. Artificial intelligence arrived at the video games. Since you could play Pong on this machine against the computer. You did not need any more a second human player. You could play it against the computer. And here on the blue, yeah, it's a bit complicated since the graphics is very, yeah, okay, here, let's take the black and white. The black and white. It's very difficult for me. Okay, yeah. And we ask ourselves how this artificial intelligence had been put into 4 kilobytes of memory, where 49 other games are also stored in this program. And perhaps you heard about it, but it uses a specific algorithm to mock artificial intelligence by always put the club, the computer tennis club, at the same height as the tennis ball is. And if you play the ball forth and back, you would see, okay, the computer tennis club becomes more arrows. After playing 5 parts forth and back, the computer won't hit the ball anymore. But if the ball strikes the upper or the lower wall of the tennis court, then the computer tennis rack is again at the same height as the ball is. So we see here a kind of artificial intelligence that only seems artificially, that only seems intelligent. And here, next to this, there's another even more interesting Pong machine. It's called Blip. Blip is an electromechanical Pong. I switch it on, and here you can see you have to put some mechanical force into the machine, just if it were a clock, and then you can start, and here you have to try to hit the number where the ball goes, and most times I'm not fast enough to return it correctly. And we were amazed about the question how this random process has been applied to an electromechanical machine. So I bought another one, which is defective, so it just costs some pennies. And here you can see there are different gears built into the machine, the little gears that are used for steering the Pong ball from the left to the right. And here are 3 different gears that are entangled with each other. And so we have a random number generator. We have to count the teeth of each gear to see how good the sequence of random numbers is. So when it will repeat the process of choosing 1, 2, or 3. So this is, I think, a very interesting way to look at random number generation with mechanical tools. Okay, I see I have another 5 minutes, but we forgot to load the program. The last thing we did in another course, in a side course of the Pong Studies course, was to program our own Pong game, to see how to implement such a game in software, what we are losing when we do it in software, and what we are finding about, just a moment, finding out about Pong by translating it into software. And this was programmed with 6502 assembly for the Commodore 64. And we managed to program this, and now I have just loaded, and perhaps some of you know the C64's loading speed, so this will take a while. But while it is loading, I can show you the source code. You can see the Pong code written in assembly language. And one thing which was very intriguing was to find out that the C64, which only uses 1 megahertz of clock speed, is way too fast to play Pong against a human. So we had to think about how to slow it down and find out processes like programming waiting loops or use other programming techniques to slow the machine down so we can play Pong against the machine. And that was even interesting for reprogramming the sound, since we have to find out what are the frequencies of the Pong sound, and to build an algorithm that plays on the sound chip of the C64, the SID chip, the frequencies we needed for the Pong sound. So here, by reprogramming the game, we got a very different insight into the technology of video games and into the technology of computers that you can't gain from just looking at the aesthetics of the surfaces of the game. So at this point, I hope the Zoom. I hope we are online. At this point, I will stop and yeah, thank you for your attention and waiting for your questions. Thank you very much.
Thank you, Stefan, for the very functional and operative presentation. Really interesting. So now we will move on. We will have a discussion. I have some questions here. I want to start with, let's say, some kind of summary of these presentations. I will say that only when operative media are present, they are in time, otherwise they are history. And from this follows the importance of time in the understanding of media and the way technical media disrupt history. So history as a temporality based on writing. And Willem Flusser, another media theoretician, philosopher, has a book entitled to the question, does writing have a future? And I think we can turn this question into the question, does history have a future? And this is a question I would like to pose to you and also add something. So if the future of the history in the above mentioned sense is digital, let's say if nothing else because of the entropy of the material, then the history will eventually become digital archive. And digital archive is something that is based on different media logic from writing and history and so on. So Wolfgang, perhaps you can start.
Yeah, thank you for this inspiration. Well, there is an important relationship between media and time, in the sense that I would say the definition of media are only media when they are happening in time. For example, most people would say, this is an old radio, this is a medium. This is the medium radio. But now, like this is not in a medium state. It doesn't process signals. It's just a piece of furniture or metal. I have actually to switch it on, and then it will start to heat up and produce noise. And I would say a technical object is only a medium when it is processing time, when it is acting in time. Now, this is the one relation between media and time. It's the core definition of media themselves. Yeah, now I hear the sound of Heidegger's radio. Sounds very noisy. Okay. And with the digital, something strange happens. As media philosopher Willem Flusser wrote, once we start to code time, like writing, it's coding time. Speech becomes symbols, I, A, B, C, D, E, F, G, or the numbers, 1, 2, 3, 4, 5, styri, and whatever in Slovenian it is. Then it loses its contact with physical time, and it becomes atemporal, because we can find in the sand of Egypt old Greek texts, and after 2,500 years, if we know the code, the alphabet, how children still learn it in school, we can speak aloud what the author wrote. And 2,500 years don't make a difference. So we have a new kind of atemporality in the digital age, which Flusser actually called the end of history, the post-histoire. So that's my spontaneous answer of this important question of how do media relate to time. Now, Stefan Höltgen, what's your attitude to media and time?
Okay, yeah. It sounded a bit like a poem. What is the future of the past? Of course, there are some problems of archiving these things I just showed you. When Wolfgang Ernst just said switched off radio isn't a radio since it's switched off, then the question is how to preserve the radio as a medium for future users or for future questions. And then the idea comes to digitize it somehow. To digitize it like nowadays we use web stream radios, and you can hear nearly every radio station on your computer as a web stream. But as Wolfgang Ernst would say, this is not radio. This is not radio, but this is internet. And the same thing is with these old computers. you can try to use an emulator, but with an emulator you get specific problems like how are the compounds of the computer, especially the analogic compounds, are digitized or put into an emulator. So you will always get a kind of you will always get the C64 as the as an emulator, but not a specific C64. And the specificity of a C64 depends on the things that are built in, like the electronic compound, but also on the gadgets the former users put onto the C64 switches and things like that. That make the machine very specific, and to emulate these specificities, you have to write thousands and thousands of C64 emulators. So the question of what the future will know about a computer from this era, a C64 computer, or even from an analog computer, is not answered yet. But it seems that for me, it seems to be very important not to forget the hardware, to collect them, to restore and repair the hardware, to see how it worked or how it works, and to get a specific idea, and to do this now and in future. So the future of the history would perhaps be not history, since you can't repeat history. If you reenact history, then you will always get a present idea of that history. But to save and to store specific ideas and specific compounds and materials to get an idea of the material past and not only of the symbolic past or the immaterial past.
Okay, let's stay with another question about media and time. Wolfgang, in recent years, you were dealing a lot with the notion of sonicity. Actually, it's your concept. You invented the concept of sonicity, with which you analyze this technicity of time, so the understanding of time with technology. And you're stating that this is a condition of ahistorical temporality. You already talked about this, obtained from the analysis of the way media machines process time with the recording, storage, playback, processing of signals and informations. So in short, if we want to understand time, we must analyze the notion of frequency or clock time in computers, processor units, and so on. But in your recent articles and lectures, you're stating that digital computing is more counting than timing, and the time is not plausible for contemporary digital conditions. So can you explain a little bit this? And my question is also, is the notion of sonicity, so this implicit this implicit sound in the machines, still pertinent for your understanding of media, or for today's understanding of media?
Yeah, thank you. I will come to sonicity immediately. Before, I would quickly say it's a wordplay which works in English, in French, and in German. I don't know if it works in Slovenian. Human culture and humans tend to tell stories, to narrate, to recount, whereas digital media can always deal with numbers. They can only count. So while the human culture is very narrative, and we tell stories to each other or to ourselves in our memories, the computer, the digital technology, has no ideas of stories. It just counts. It does not recount, it counts. And there I see a dramatic shift how humans live in technological culture. Now, to come to the term of sonicity, I want to say here, this place, the Media-Archaeological Fundus, is the physical space which links our department of media science with musicology. If I go around here, there is a door, and suddenly I'm in the music department. Now we are together one institute, media science and musicology. This is different from most media studies, which are only visual orientated, film studies, television studies, interface studies, visual. But we have ears. We are one of the few media sciences which have ears. And sonicity comes in. We talked about the relation between technology and time already. Well, it is the ancient knowledge about music and sound which linked human culture to time. This is cultural time. That is musical time. Now, for many years, music is only what our ears could hear acoustically, sound. What I call sonicity is the kind of music which happens inside technological media. To come back to the radio, we think radio is, we can hear radio, the sound, but this is the loudspeaker. We actually don't listen to the radio as technology. The radio as technology, as we see it from the inside here, this is the reception of electromagnetic waves. We cannot hear electromagnetic waves. I cannot hear the WLAN, for example, or the digital impulses in the room. But if the technology has ears for the musicality of signal transmission. Analog waves, that would be the traditional sound, or digital pulses, which would be rhythm. And even the computer inside is processing software in a highly rhythmicized way. That's why our colleague Shintaro Miyazaki actually writes the term like this: algorithm. The algorithm merges the mathematical algorithm and the musical rhythm. Now, this happens in all your computing devices, in all your smartphones. There is musicality inside, not explicit acoustic, but implicit sound. And that's what I call the inner sonicity of media technology. That's why I tried to say how technology is very musical in its temporal essence. And that's a fascinating link. And that's why I'm happy that this place here links music, ecology, and media science. That was my answer. Yes.
Thank you. So if we sonify sonicity in technology, amplify it, we get noise. So, Stefan, my next question is actually regarding the noise. So you were talking about errors, but in your title of today's presentation, you also mentioned noise, so yeah. Signals and noise. And I want to ask you, what is the relationship between error and noise? So since the noise is an immanent, inherent part of technical media.
The easy answer would be going back to Shannon to see that if you have a communication process and even machines communicate with each other, then the channel is oftenly victim of noises, of incoming signals that disrupt or change the message that is sent through the channel. So this is the easiest way to see noises as sources of errors. But noise is not only a process of error. Noise is a process of randomness, and very often noises are used to build like random numbers, or are used to build specific sounds in media technology. Most of the machines here in the Signal Laboratory, or some of those machines, are using programmable sound processors, sound chips, so-called sound chips, and all of those sound chips have a noise generator, a built-in noise generator, and these built-in noise generators are used to make like percussion sounds, where you want to add a noisy sound to the instrument sound, and some of these sound chips are even used in noise production for generating random numbers. And an interesting question is how to produce errors and how to produce noise how to produce noise that is not an error, but a wanted thing to put out or to use. So how to produce random numbers or how to produce noise with a computer, which is a very I've lost the words. Which is a machine that can't produce randomness. That can't produce randomness, and there are specific algorithms and specific ideas to put those kinds of noise into the machines to get random numbers that are better than other random numbers that can be used for encryption messages and so on and so on. And by looking at these algorithms, you can see and you can understand all, on one side, the cultural history of randomness and of statistics and stochastic. And on the other side, you can kind of read the history of the computer age by looking at the algorithms that were used to produce random numbers. You can see the random number generators from the 1950s and say, okay, these were used for Monte Carlo simulations. And you can look at random numbers that are used nowadays, like Mersenne twisters, and to see what they are used for. So every epoch of computing has its specific noises that are used in purpose and not as errors. And some like with these analog computers, technologies had been invented to cut the noises, to get the drift out of the operational amplifiers, to get a better number. But with digital computers, it's another thing to think about noise, since noise is mostly a wanted thing to get from a digital computer and not an error.
Let's talk a little bit more about your collections. In Fundus and in the lab. So I want to question you both, maybe to mention some other artifacts from your collections, and also to talk a little bit about the concepts, questions, problems you're working with in the lab in the Fundus. And specifically, do you include code and software, or do you have any idea for the future how to include code software in your collections, for example, such as repositories such as GitHub, online repository for software? So is this method, for example, suitable for your engagement with media, which is more hardware oriented?
It would be a narrow idea of media archaeology if we only reduce it to reminding of the material aspects of media, because most people think media nowadays is all software. Now, the media philosopher Wilhelm Flusser, who was already mentioned, he wrote an interesting essay about things and non-things. Classical analog media and even digital computers are still physically 100% hardware. But the essence of the computer, different from a clock, for example, is of course software. Now, can we put software on a shelf like we have other things here in our media-archaeological collections? How can we show and collect and display something which is not a thing, but a non-thing, ein Unding? Now, this is software. But that brings us to a very essential questions of media philosophy. The Berlin school, including Friedrich Kittler, always insisted that software is an ideal concept. Software, in order to operate, has to be embodied, implemented. It has to become translated into matter, and only then software becomes active, becomes a medium, becomes temporal. And that's why I just pick one thing from our collection of storage media. Now, this is a classical piece of punched card. Now, it even says Fortran. This is one of the earliest computer languages. Now, this is a piece of software, but I can touch it. It's on paper, and there are holes and there are non-holes. Now we see how the computer and the digital and software is not really about zeros and ones, but the zero only exists as a whole here, and the one is the paper resistance. And that happens in electronics as well, in different media. So from here, the very essential question opens. Is the software something on the logos, on the idea side, or is it on the material side? Colleague Friedrich Kittler wrote a world-famous article which says, there is no software. Every day, everybody would say, no, I'm always using the apps and the software on my smartphone. Of course, there is software. But if you try to look at it, it becomes materiality. And the oldest European question of philosopher Platon comes back. Is there something like a pure idea that would be software nowadays? Or do we have to think pure idea and matter together? Only then the word technology makes sense. So software is both a challenge and an invitation for our Media-Archaeological project, which I can now hand over to Stefan Höltgen to the Signal Laboratory.
Of course, if you collect computers, analog computers or digital computers, the software is a topic as well. So we use software, and we have software here, and we have many software, many programs here. But since we lack of space, we don't use originals, but mostly virtual software like disk images and things like that to use with the computers. Not only to save money by not buying software for our computers, but also to get those interesting retro machines working, where you put a USB port to your C64 to load software you found on the internet into your C64. This is a very modern way of software preservation, to put the software titles to the internet, since a software doesn't need a hardware container to be software. You can also virtually put it on the net. But it would be not correct to say that there is no software to store, can be stored in shelves. I asked my colleague to get a book from my office, since I don't have those kinds of books here. And this is a book which contains dozens of basic algorithms to type into computers. And as you probably know, especially in the 1970s, 80s, and 90s, you could buy magazines and books full of software. It's a kind of text, a sort of text that is very specific for this age of computers. So when you ask me, do I use things like GitHub or anything like that? And not now, since we don't produce any new software here that is worth to put on GitHub. But we are more interested in those gray literature, like these books and the magazines and the fan magazines and the printouts and even the scribbles the people did in the 1970s and 80s to look at the software that has been written on paper, where you can read the programs and try to understand the programs and type it into your computer. But you can also read the understanding of programming of the writer and of the people who wrote that books and that programs. There you get an idea of different styles of programming styles, especially from this amateur and hobbyist scenes where the people program. But these archives are not yet digitized, so we can say it's preserved very good. They are waiting to be digitized and they are waiting for their researching, for the researching of codes and of styles and of programming languages and of scenes and things like that. So I would say the software problem is not only a problem of storing software anywhere, but of the question, what is software and what kinds of software are produced in the history until today. We can find ROM chips with software, which is actually hardware. We can find core memories that save magnetized bits from the past, where we can't read them, since we don't know from which computer this core memory is. It's as with the punch card Wolfgang Ernst just showed. You can't find out what this is, what these punched holes means if you don't know what the whole program is and what the computer is where these programs had been loaded or had to be loaded into. So these questions are more interesting for us. It's a more epistemological question about software than a practical preservational question, but it goes hand in hand. I would argue you can't research the history of software and the materiality or immateriality of software if the software isn't here anymore. So somehow it has to be preserved.
Wolfgang, let's talk about your new book. So your new book came out just recently, I think a week or two ago, if I'm not wrong, titled Technologos in Being, Radical Media Archaeology and the Computational Machine. So as the title suggests, the focus of the book is on computation, computers and so on. And I suppose you understand computation as a reasoning embedded and conditioned by the machine itself. So the things we are talking about here. So can you please tell us a little bit about the book, and also do you or how would you approach different algorithmic methods in their development, for example, commander systems, streaming platforms, or even more concretely, social media from the perspective of radical media archaeology?
It's about computing, but there is one chapter, I'm proud to say once more, symbolical reenactment of machines from Hugo back to Babbage, because it's how you can construct a computer on purely mechanical means. And just like Babbage's difference engine, the first programmable computer in 19th century, was driven by steam and could be assembled and reassembled from purely mechanical parts. This Hugo manual allows you to reassemble a fuel-driven machine. So you can actually rebuild the Hugo car and use it as a computer if you construct it in a different way. But this is the anecdotal side. The core idea of my new book, Technologos in Being, is the question which I already mentioned briefly. Normally, our idea of technology and media is very anthropocentric. The humans are still the creators. The humans are the inventors of machines and of progress. Now, Technologos takes the other point of view. Media-Archaeology takes the point of view of technology itself. And that would say, is it humans invent technologies, or is there a technological knowledge which in a way has a logic of its own? That comes close to the philosophy of Gilbert Simondon, who insisted there is an autonomy of technological development, which is not simply controlled by social, economical, or cultural human will, but has a logic of its own. And it's to take this clock again. I write in one chapter, I write about the automatic piano, the self-playing piano. What is happening there? It's like with this clock mechanism. As Karl Marx wrote in his famous Machine Fragment in 19th century, of course, nature does not grow a mechanical clock like it grows a tree or grass. On the other hand, this mechanical clock consists of 100% nature. Our traditional philosophy would say human knowledge, human will, human ideas, they imprint their will on matter, and then they create machines. It's still the human who informs matter or energy. But I say now, once human ideas are coupled to matter, matter starts to develop a logic of its own. So I grant technology a will of its own, and that's why I write Technologos and not simply technology, Technologos. So that's the core idea, to de-anthropomorphize the idea of technology. That links up to so-called object-oriented ontology and other theories of the present day. But the great drama which happens, and I try to describe this drama in my new book, is what happens if the symbolical order, the ideas, the human cultural knowledge confronts matter and energy.